right, everybody, welcome back. We are diving deep today into something that is uh, both incredibly fascinating, but also a little unsettling. And it's the intersection of encryption with AI and quantum computing. And the reason why this is so important to dive deep into is this is really the future of data security.
Absolutely.
Here's mine, everybody.
Yeah, the very foundation of online trust and security as we know it.
Exactly.
Yeah.
So let's start with what we currently have right now. We've got encryption algorithms like RSA and ECC.
Right.
These are kind of like the workhorses of encryption.
Yeah, the backbone.
Exactly. But there's this kind of new kid on the block, and it's called quantum computing.
Yeah.
And it's not here to play nice.
No, not at all. And quantum computers, they operate on a fundamentally different level than classical computers. And because of that, they have the ability to solve certain problems exponentially faster.
Okay.
And that includes potentially, the factoring of large numbers, which is exactly how RSA and ECC get their security.
Got it. So it's not just that quantum computers are faster. They can actually, break the math behind what we use.
Exactly. Like imagine a safe that has a combination lock, right?
Yeah.
A classical computer would have to try every single combination one by one until it got it right.
Right.
A quantum computer can, in theory, analyze the mechanics of the lock itself and figure out the combination almost instantly.
Oh, wow.
Obviously a simplification, but it gets the point across
Right.
of the threat that this poses.
So that is a kind of terrifying thought, because that would mean that everything from, financial transactions to national secrets could be vulnerable.
Oh, absolutely. And the scale of the potential damage that could be done is huge.
Right.
I mean, widespread data breaches, economic disruption, even national security at risk.
Okay, so we've got this quantum threat
Right.
looming on the horizon, but we've also got this other technology, which is AI, and
Yeah.
it seems like it's everywhere these days. So where does AI kind of play into this whole encryption puzzle?
Well, AI is interesting because it is both a threat and a potential solution to this problem. On the threat side, we're already seeing it used to craft these incredibly sophisticated phishing attacks.
So those are the emails or messages that are trying to trick you into giving up passwords or personal information.
Exactly, but these aren't the average phishing scams that we used to see.
Right.
AI can analyze huge amounts of data to create these really personalized and convincing messages. And it makes them that much harder to spot.
Wow. It's like having a con artist tailor a scam just for you.
Yeah, exactly.
That is pretty unsettling.
It is.
So I guess that means it's not even just about having stronger firewalls anymore.
No.
It's also about outsmarting these AI-powered attacks.
Absolutely. And it goes beyond phishing, too.
Okay.
AI can be used to automate cyber attacks, making them faster, more efficient, harder to defend against. And then there's AI-driven malware
Oh, wow.
that actually adapts and evolves as it goes, trying to bypass our security measures. So it's really hard for traditional security to keep up.
It really sounds like a constant cat and mouse game.
Yeah, it is.
So how do we fight back against all these evolving threats? Is AI the answer?
Well, it can be, and that brings us to the solution side.
Okay.
And that is post-quantum cryptography.
Post-quantum cryptography.
Or PQC.
PQC, got it.
And this is a whole new family of encryption algorithms that are being developed specifically to resist attack from both classical and quantum computers.
So is it kind of like we're building this fortress that can withstand any type of siege engine, whether it's from medieval times or from the future?
I like that analogy. Yeah, basically, it relies on different mathematical problems
Okay.
that are much harder for quantum computers to crack.
Okay.
So some of these promising approaches are things like lattice-based cryptography, code-based cryptography, and hash-based cryptography.
So these PQC algorithms, are they ready to be deployed right now?
Not quite yet.
Okay.
It's still a very active area of research and development, and organizations like NIST, the National Institute of Standards and Technology, they're working really hard to try and standardize these new algorithms, but it's a race against time to get this implemented before large-scale quantum computers become readily available.
So with all this in mind, where does this leave us? What is the takeaway for someone who is, trying to navigate this very complex world of encryption in the age of AI and quantum computing?
Well, I think the key takeaway is really awareness.
Okay.
Understanding the threats as they evolve, but also knowing that solutions are being developed and being prepared to adapt, to move beyond our reliance on the current encryption methods that we have.
It really sounds like this whole world of encryption is about to get a lot more complex, but also a lot more interesting
Oh, yeah, absolutely.
as these technologies continue to evolve.
Yeah, and staying informed and adaptable is going to be more important than ever before.
That's right. And on that note, something to consider is what are some of the ethical implications of AI's growing role in cybersecurity?
Hmm.
Like, what safeguards do we need to have in place to make sure that this technology is developed and used responsibly?
That's a great question, and one that we all need to start thinking about now.
Absolutely. Well, thanks for taking this deep dive with us today. It's been a fascinating conversation.
Yeah, it has been.
And to everyone listening out there,
Yeah.
stay curious, stay informed, and let's